Hi folks, in this video I want to talk to you about the interview process of getting into a large software company. I will talk specifically about Google because I went through the Google interview process and I got hired by Google. I worked there for about a year, and while I was there I also interviewed others to get into Google. And I noticed that while interviewing for other companies like Twitter or Facebook or Amazon, the interview process is quite similar to Google. So what I say here applies to most of these companies. So I'm going to go through what kind of questions they ask, and then what you need to study in order to be able to do well there, and what you should pay attention to, basically, to perform well in your Google interview. Okay, so let's get started. First, I want to talk about the various positions that you can apply for at Google, and there are basically three kind of positions in terms of level, and these are the first one is going to be an internship. So an internship, but not any kind of internship, but the STEP internship. So that's the lowest level. Inside Google, we call this level 1. And this kind of level, I recommend it. If you can get that internship, I recommend it because the interview is going to be much easier for you. If you get accepted as a STEP intern, this is going to be a 3 months position during the summer, and you will have great prospects of doing another internship with a company. So if you make it into your first STEP internship, then you can get a proper internship in the next season. The bad thing about STEP is its salary is slightly lower than the full internship, and you can only apply to this if you are a first year computer science student. Sometimes they also accept second year. So if you are just starting a computer science degree and you just finished your first year or maybe your second year, then this is what you should apply for. This is what I highly recommend doing, because once you get into Google, you will see the culture inside of it, and you will be able to see if you like it and if you want to apply again. So again, first or second year is the summer, and it's also 3 months. Okay, and then the second kind of position you can apply for is a full internship, and the full internship is available to all students studying computer science. You can be an undergrad, first or second year, or higher year. You can be a master's student. You can be a PhD student. This is level 2 inside of Google. And this is also easier to get into than a full-time position, but this interview is going to be slightly harder than the internship. So I highly recommend, if you plan to work full-time for Google, to go through the internship, because you will be able to work for a short amount of time. You will be able to see the interview process, you will be able to meet people there and see the company culture, and that will give you a huge advantage if you want to get a full-time position. And so this is higher years. You can also get a full internship if you are first or second year, but I don't recommend that because the STEP internship is easier to get into. So why not take advantage of that? The internship is usually 3 months, maybe up to a year. Sometimes you can do up to a year. For example, Twitter does up to a year internships, and then this can be the summer or it can be during the winter. And then the third kind of position you can apply for is a full-time position. So level 3. And then this is usually long-term. So another reason why you can do an internship is that you can stay there for 3 months, and then you can go back to school and no questions are asked about why did you leave after just 3 months, right? So the bad thing about the full interview is, of course, it's more challenging. So these are the types of interviews that you should expect, right? So I'm going to talk about all of them. They are not very different. The basic ideas are the same. So what is the interview? What is the interview about? So First of all, the Google interview is not uh, like a laid back interview. It's a very technical interview. So you will be asked technical questions, and these are going to be about coding, these are going to be about systems, they're going to be about science and engineering. They're not going to talk about things like your CV so much. You may spend like 5 minutes at the beginning talking about your CV and what you did. They're not going to ask open-ended, silly questions like what do you want to be in 5 years, or what's your biggest weakness. They don't care about such things. They care about your technical ability. So while you're there, your interviewer wants to know if you know your stuff, if you know what you're talking about. So they're going to ask you a technical question. The interview is going to last for 45 minutes, and it will be a problem. So it will be a technical problem. You will be asked a problem. You will be given a problem, and then you will be asked to solve that problem. And that's the whole interview. And they will expect you to write code during your interview, not just to talk through the solution at a high level, but you will be expected to write code at a whiteboard. So code at whiteboard. Now, this is the first point that I want to make. If you have not used a whiteboard to code ever, this is going to be challenging. Even if you are a good programmer, the whiteboard coding session is hard. So if you have taught programming lessons to others and have written on the whiteboard, that's going to be a big advantage for you. But if you haven't, then you should train. You should put aside 2 weeks before your interview and do coding on the whiteboard every day, and make sure that the code that you write on the whiteboard is properly written. It's actual code. It compiles and runs without mistakes. So this is important. It must compile and must run. So you're not expected to write pseudocode. You're expected to write actual code as you would write on a computer, and you don't get the chance to compile it. You don't get the chance to test it using a proper compiler. Now, the Google positions are two different positions, two different types of positions. The first position is called an SWE, SWE, which means software engineer, and the second type of position is an SRE, and that's a site reliability engineer, or a system administration, or DevOps. So if you want to apply as a software engineer, this is what I'm going to talk about today, the software engineering position interview. And I want to say that these are generalist interviews. So Google will not interview you for one particular position. If they want you to work on Google Maps, they will not interview you for a Google Maps position. They will interview you in general for getting into Google, and then afterwards they will ask you to join a particular team. Or you may also be given the choice of joining one team or the other. So let's make sure that this is clear as well. This is a sysadmin position, or reliability engineer. In the SRE position that I'm not going to talk about today, you are a sysadmin who also writes code. So this is like a DevOps position where you get to own systems, you deploy them, you automate things. But my interview was SWE. So I interviewed as a SWE, and I interviewed people as SWEs, so I'm going to talk about that today. And the important thing here is that the keyword is generalist. So you may be asked very general questions for a wide area of different problems. You may be asked to solve whatever problem the interviewer has in mind. They can be various, and your specialization does not matter so much. So if you're very good at security, for example, or if you're a very good cryptographer, this doesn't matter if you're not very good in like a wide variety of areas. So you should know your stuff. You should know generally about computer science, and have a general idea about how systems work, not just specific knowledge. Okay, so that's like the preliminaries, and then let's get into the actual interviews. There's two types of interviews. The types of interviews that happen at Google are screenings, and then there's also the actual on-site interviews. So there's the phone screen. and the on-site interview. So these two types of interviews are all on the same subjects. They will not be very different, but I want to just briefly touch on what they are so that you feel comfortable during their interviews. So the phone interview is something that they do first. They call you up either on Hangouts or on your phone, and they ask you a few questions. It's about an hour, or maybe 45 minutes to an hour, and it's a technical interview. Like I said before, all of Google's interviews are technical, and this one's going to be easier. So this is just um, to see if it's worth it taking you on site, basically. And you may do one or two of these. If on the first one they're unsure, they'll give you a second call. And if you're an intern or a step intern, maybe all of your interviews are going to be phone screens. So if you're far away, if you're in a different country, they may not bring you on site for the interview. They may conduct the other interviews on site. So for your internship, you may get like 2 screenings, for example. If you're interviewing for full time, or if you live in a country where Google is located and they can bring you on site easily, they will also do an on-site interview. If you're interviewing full-time, usually if you do well on the phone screening, they will fly you to a Google office and you can do the on-site interviews there. So on the rest of this video, I will focus on the on-site interview, which is on the same subjects basically that they're going to do on the phone screen, but this one is just a little bit harder. So there's not much difference between the two in terms of subject. It's just the difficulty that is different. So yeah, the on-site interview is going to be a local interview. You walk into the Google office, you get your flight paid for by Google and a hotel, and then in the morning you go to work. Basically, you go to the Google office. It's a 9 to 5 interview, or maybe 10 to 5. It's a full day, and it's going to be maybe 5 interviews back to back. So each of these is going to be 45 minutes, and you're going to also get a lunch interview, which is basically a bonus interview where you get to eat lunch with a Googler and they don't ask you technical questions. So maybe it's going to be two or maybe 3 interviews before lunch, then it's going to be lunch, and then 2 interviews after lunch, something like that. And the lunch interview you shouldn't worry about because it's not counted towards your score. Of course, I mean, don't say something very stupid. Don't make your host feel very uncomfortable, or don't say something racist or sexist. But other than that, if you're a normal person, it shouldn't matter to you. You're not being judged on it, right? Yeah, that's it. And then let's move on to what these other technical interviews are, what these on-site interviews are. What are the subjects of these interviews? What do they ask, and how can you do well there? So let's see. Let's fill in the whiteboard. Okay, so you will be judged on 3 different things. They will ask you maybe different types of questions to judge you on 3 different areas. The first one is going to be coding, what we call coding, and I will explain in detail what this means. The second one is going to be algorithms, and the third one is going to be design. So algorithms, and the third one is going to be design. Okay, so I will go more deeply into these things one by one. So let's start by coding. Well, in coding, the interviewer wants to know if you can code, if you can write code, because this is what you're going to be doing at Google day to day. As a SWE, this is your job to write code. So they will expect you to be able to code proficiently, and that means you should write good code. They want you to code quickly. So don't take the whole like 45 minutes to write a for loop, and then without mistakes. What does without mistakes mean? Well, that means the code you write on the whiteboard should compile. It should not have missing semicolons. It should not have off by one errors. I mean, you will not be rejected for that, but it makes a good impression if you can write it well. And then in general, they will want to see if you use good practices. So what are these good practices? Well, they could be, for example, defensive programming to use asserts in your code to check your inputs for correctness. Maybe you can ask the interviewer if they want you to write unit tests or other tests, and they can tell you yes or no. But it shows that you are testing your software. And then of course, quickly is a bit of a misnomer, because if you code too quickly, then that's a red flag. The problem is if they ask you a coding question, it will sometimes be vague. It will be something like, I don't know, to implement something like, let's say you are given some points on a map and you want to find whichever points are closest, right? This problem statement is not clear. It doesn't tell you closest to what. It doesn't tell you how many points there are on the map. It doesn't tell you if the map is 2D or 1D or 3D. It doesn't tell you if the coordinates of the map are given in longitude or latitude, or if they're given in X and Y. It doesn't tell you if the coordinates of the map fit in memory, all these things. So the first thing to do when you see a coding problem is, before you go in too quickly to write the code, you should think about the question and think if it is clear. And if it is not clear, you should ask as many questions as to clarify the problem statement. So try to figure out what the statement is asking before you go to the whiteboard to write code. You should ask questions about the data. Does the data fit in memory? Does it fit on the hard drive? Sometimes Googlers enjoy asking you scalability questions. So maybe the data will not fit in a single server and you will have to use multiple servers. And you should definitely understand the problem from an algorithmic point of view. So what is the input and what is the output you should expect, right? So ask questions. This is very important. And you're judged on that because during your job, you will need to ask questions and you will need to talk with your colleagues about various problems and you will need to discuss them. And so this is a good quality to have as a software engineer. You want to be able to explain your thought process. You want to be able to explain your questions, and if something isn't clear, you should not be afraid to ask. So just ask away, and once the problem is very clear in your mind, and once you know how to solve it, you should then go to the whiteboard and code. But if you're not sure how the problem is solved, I think you should talk about the algorithm with your interviewer as you would with a colleague. So tell them about your idea on how to solve the problem. Say, okay, I will write this for loop and I will do such and such. In the same way you would talk to one of your coworkers or one of your fellow students at school. And if it seems to be going well, then you can try and write out a coding solution. Your interviewer will very rarely ask you to go to the whiteboard and code. When you have figured out your solution, it will become clear to both of you that it's time to write the code. So you can ask them, should I write the code now? And they will say yes. And so, yeah, that's it about coding. And they will also check your style. So use a good coding style. That's important. So that's details like coding style. Details like indentation, details like variable and function naming, spacing. Prepare to code on a whiteboard. If you have trained on writing code on the whiteboard, as I said previously, you should leave some space to define your variables. You will get used to that so that your whole code is not crammed in a single line. So this makes a good impression, right? The code is readable. Now, here I wrote without mistakes. Of course, it's impossible to write perfectly good code in a Google interview, because the problems are usually difficult. So you will definitely make mistakes, but if you minimize your mistakes, that's good. However, at some point you may have a bug, and your interviewer may say to you something like, "Oh, I think you have a bug," and then you probably do have a bug if they say that. So you should step back and look at your code, and maybe run an example, right? Run a test case. Um, and you should run it out loudly, like say the input is such and such, and go through your code and explain what you're thinking and see if you can find the mistake. Like debug it in the way that you would debug a real program, except this time you don't have a compiler and you don't have a debugger. And if you're stuck, you can freely ask your interviewer for a hint. You can say, "I can't find my mistake, maybe you can give me a hint." Um, I think it would be arrogant to say, "No, I don't have any mistakes, my code is right." Something like that is kind of a red flag, and I would not recommend it. In general, it's very important to talk through your solutions, speak up, speak through your thought process, and describe what you're thinking to your interviewer. Say the first thing that comes to mind, and then try to improve it and see what they say to you, and so on and so forth. If you just sit there in silence and wait for your interviewer to speak, or just think about the problem solution while your interviewer doesn't know what you're doing, this is not really illustrating anything to your interviewer. And then I think you should know these languages. So I think you should know C, C++, you should know some Java, you should know some Python, and then you should also know some web languages. You should definitely know your HTML, CSS, and JavaScript. And if you can know, maybe if you have some bonus languages there, like maybe Go or some functional language such as Haskell, these are bonus points. So these are quite popular languages, all of these, and you are expected to know them. You will be allowed to code in any language of your choice, but different problems call for different solutions. So if you're asked a very clear algorithmic question, then C++ is very good for this, because you can use STL, the standard library, and all of the data structures that it offers. If you're asked a more like practical problem, you can use Java or Python, where you can write more concisely. If you're asked a problem about the web, you can code it in JavaScript. And sometimes a problem calls for a functional solution. And if you're asked a low-level question, like a secure coding question, or how to implement a data structure, you can use C. So it's very good to know all of these languages so that you can use the one that is more appropriate for the problem. I recommend that you know all of these languages and you've written code in all of them. And one way to do this, one way to practice this, is you can go to this website, projecteuler.net, which has various very simple problems. And you can go ahead and look at these problems. For example, problem 1 says it's like a very simple problem where it tells you, look at the numbers below 1000 that are multiples of 3 and 5, and you should sum them up, right? And then once you log in here in the Project Euler website, you can submit your solution and see if it's right. So if you want to train in these languages, C, C++, Java, Python, JS, you can go ahead on Project Euler and maybe solve the first 20 or 50 problems in a language of your choice, and this will be a good way to improve your basic skill in this particular language. That's it about the coding skill. They look to see if you have good coding abilities, and well, of course, learning these languages at a basic level is good, but you should also know good general software engineering practices. And the way to improve that, as I will talk about in the design section as well, is to write actual production code, and I will get back to this. Now let's move on to the second kind of skill that is, and that skill is algorithms. And so number 2 is algorithms. And let's see what kind of questions they asked. I will talk about a wide variety of areas that you can train in, you can improve in. And if you know all of these areas, then you will do well in your Google interview, and then you will do even better in interviews at other companies like Amazon. So algorithms. In algorithms, this is standard stuff that you will do in a computer science undergraduate course of algorithm. So it will include graph algorithms, and then in graph algorithms, you're expected to know things like searching. So the simplest thing you can do in graphs is like BFS and DFS. You will be expected to know some shortest path algorithms like Dexter and Bellman-Ford and so on. They may not ask you about like specific algorithms, but if you if you know these things, you will have prerequisites to solve any problem that comes along your way. So it's good to know. They may not ask you to implement Bellman-Ford itself, but if you know it, it has good techniques that you can rely on for solving any problem. Floyd-Warshall is another classical algorithm, and then some flow algorithms, some maximum flow algorithms like Ford-Fulkerson. Um, these are good because there's many problems that you can reduce to these. So if you work with these ideas, you can say, oh, this problem is just a max flow problem, or this problem is just a shortest path problem on a graph, and so you will be able to solve it easier just using standard tools. If you see a problem that is a standard algorithmic problem and you just try to solve it on your own without mentioning that it has been solved by Floyd previously, this is kind of bad, right? Because we should know the literature and what has been done before. Now, you should also know some dynamic programming. And in dynamic programming, you're expected to know how to solve problems with dynamic programming and multiple dimensions. So say 1D, 2D, etc. And you're also expected to be able to make like correctness arguments for this. Maybe not full formality proofs, but just to understand why is your algorithm correct, and of course to be able to write your recurrence relation. So your recurrence relation is a mathematical tool to explain the correctness of your algorithm, and of course you should also be able to approach problems greedily. So that's one thing, and then of course you should know your data structures. These are useful tools, and if you know the right data structure, the problem becomes much easier. Some data structures that are useful are, of course, things like arrays, maps, queues, stacks. These are like the basics. But if you know some more advanced data structures, it will definitely help. So things like binary search trees or self-balancing binary search trees like AVL trees and B trees. They may ask you like a database kind of question with B trees or B star trees, and then some more advanced data structures like segment or binary index trees are very useful. Segment trees or interval trees, let's say. These are super useful, but you may not necessarily need them. And then sometimes they ask like specialized questions. So if you know some specialized data structures like KD trees, you can solve things like the map problem I told you about before. So this is super useful, all kinds of trees. And then the other kind of data structure that is quite useful is to know some string data structures. So things like tries, because if you are faced with a string problem, this will be very valuable. And then some classical algorithms, like some classical algorithm techniques, I should say, like string matching or the idea of a sliding window. These ideas are quite important to know as tools. So you should know these things. And then, of course, once you write your algorithm, you need to be able to analyze it from a complexity point of view. So from a complexity point of view, you need to know your computability and complexity classes. So just basic stuff, not something very advanced. So like big O or like omega and theta, You should know like what is NP complete, right? If you're given an NP complete problem, you should be able to argue, oh, this is NP complete. Maybe I can reduce an NP complete problem that is standard NP complete to this. They don't usually ask these questions because they're a little bit more theoretical, but you should not attempt to solve an NP complete problem. That is obvious, right? This is kind of a red flag as well. So this is the kind of algorithms that you're expected to know. And I know there's a lot of stuff to take if you haven't seen these before. So I want to recommend a couple books. One is CLRS, and CLRS is this book here. It's by MIT Press, and it's written by Corman Laserson Revisenstein. And this is a big book, but if you know what it says, like, it covers all the things that I said, right? Sorting, data structures, trees, graphs, and then various things like NP completeness, linear programming, and so on. And it's a very useful book. So I don't know if you can read all of it because it's very large, but at least you should know what it says inside. So this is like a rule of thumb. Look at the topics that it covers and then try to learn them. Maybe you can learn them without looking at everything in the book. Maybe you can read some things in the book. It's a very well-written book. Another book that covers almost the same things is the Vazirani book called Algorithms. And this is the book. It's by Dasgupta, Vazirani, and Papadimitriou. And this book is it's a good book. It's kind of shorter than CLRS, and it goes through the same topics. It's a little bit more concise. It's also very well written, and highly recommend it. So it goes through like number theory algorithms, graphs, and dynamic programming, and NP completeness, and so forth. So again, if you know your algorithms, if you've gone through these books, you will not have a problem. And it's not enough to read these books. You have to also solve some problems. And the Project Lawyer website that I mentioned previously has quite harder problems. So if you go up to this problem, like 161, this is a harder DP problem, for example. And it's very good to train. So if you solve 100 or more problems of your choice from Project Lawyer, this is great. Two other good sites are Spoj, which has a lot of problems that are algorithm related. You can choose the ones that you like, and you can also filter them by topic. There's many indexing sites, but there's also tags here, so you can try and solve them. And the solutions that you submit to Spoj, they need to be written in code. So it's not just a theoretical solution that you need to figure out, but you also need to write it out, which is very similar to your interview. So this is great for training for interviews. Another place is the Codeforces site. So Codeforces is also a site that has competitions and problems. You should check it out. It's good. There's other sites. There's also USACO training, yeah. So just go ahead and figure out which site is your favorite, which one you like, and you should be able to find some good problems and train in it. So this will improve your algorithm skills tremendously. And that's the second subject that you will be asked. So that's number 2, algorithms. Okay, sounds good. So we've got algorithms out of the way. Let's see what else remains for the interview. The third thing that you will be assessed on, and that is design. So design, I think this is the most difficult one. And if you're doing a phone interview or a screen interview, you shouldn't worry about that yet. Probably they will not ask you that so much. And if you're an intern, or especially a STEP intern, then they will not ask you any design questions because you're not expected to know any design. Especially like right out of college, if you're applying for a graduate position or an internship, then these are going to be easier. But if you're a veteran software engineer and you've worked in other companies before, then these are going to be quite more difficult. And of course, you're going to be asked more difficult design questions for a graduate position rather than an internship position. So yeah, that's design. So what is this about? Well, design is about building large software. So building production software, building large production software. And you have to be able to design a software from the bottom up and from the top down. So you want to be able to say, um, well, I guess maybe I can give an example. Like your interviewer may ask you something like design um, Google Hangouts, right? Let me ask you something like that. What is Google Hangout? Well, the chat part of Google Hangouts, let's say. This is one of my favorite questions. And let's say chat, right? So this is a very open-ended question. Of course, you can't code up Google Hangouts in 45 minutes. It's a huge project, and there's tens of thousands of people working on that, or maybe thousands of people working on Gmail and Hangouts. And so obviously you're not expected to do their job in 45 minutes, but you're expected to be able to build the system like in your mind, top down, right? So you should say, okay, if I want to make Google Hangouts, then that will require like a client sitting here. You don't have to write like UML, this is just a sketch. So this is like the browser, and then this is the Google server, and they communicate with like HTTP, right? And then how do you do that? Well, this is the client, I write a client and I write a server, and they talk to each other. So you need to be able to describe this protocol and go through the design of the software with your interviewer. So you will start talking about how you would approach this problem, and then your interviewer will guide you to a correct direction. So you'd say, okay, I have a client and server, and they may ask you, okay, how do you build up the server? And you can say, okay, I can use the MVC pattern. And that's another thing in the design interview. You may be asked to use different software patterns. This is a good book, The Gang of Four book, right? Is a good book on design patterns. But if you come from a software engineering background of large languages like Java, then you'll be familiar with these. But this is a good read. But most of these you can't get from a book. You get them from building actual software. And so you can say, okay, I will have MVC, and then they will ask you, oh, what is MVC? You know, and you can say, oh, I'll have models and views and controllers. And then they may ask you, okay, what kind of models will you have? And you can say, oh, I will have a chat message, and that will be one model. And then I will have also, I will have like a user maybe. And then I will have also maybe like a conversation so that we can have like group chats. And that will be exciting, right? And the interviewer may ask you, okay, what fields will the user have? And you can say, okay, we'll have a username. And they may guide you to this location, to this like to this part of the design process where you design the DBMS, right? The DB, not the DBMS, but the DB schema, right? And you're here and you're designing your ontology of the application. You're building tables and you're building fields, and that's it, right? And they may ask you what kind of normal forms may there be, or what kind of foreign keys will you have, or what kind of primary keys or indices will you have, and how will you be able to like do this quickly and search through the messages, or they may ask you like a question to see if you have a good view of what the software is doing from a high level point of view. So they may ask you, okay, the client now goes to gmail.com, they enter this in their browser, and they open up a chat window. What happens? And then you can describe that. Can you describe that? Can you describe what happens in every step? What happens in the client here? What code runs here? What code runs on the network? What code runs on the server? What code runs on the database? You should be able to do that, right? You should be able to say, oh, the server communicates with the database, and they speak a protocol, and that protocol is a SQL protocol, right? For example, it could be MySQL, right? And you should be able to say, okay, how does MySQL index things? Maybe not specific implementation details, but you should know that, oh, it uses some sort of trees, right, or some hash maps. And then they may add more difficult questions to this problem. They may say, okay, you have too many users for this to be one web server. You need to add more. you need to have more web servers. How do you do that? And then you can describe some scalability solutions. You can say, I'm putting a load balancer here in front of that, and it's talking to all these web servers, and then all of these are talking to various DB slaves of MySQL, which are talking to one DB master, and they're using some sort of propagation. So this is software design, right? How do these speak to each other? They may ask you, oh, is this protocol secure? Is this encrypted? Right? How do we make it secure? That kind of question is what you should expect in a software design, in the software design question. And the thing that they want to see here is if you can design good software, if you can lead a team of software engineers, if you have good design principles, but not in coding individual lines, but in designing large software systems. So can you do multi-tier design? Can you do orthogonality? Can you do separation of concerns? Can you separate your components in a way that they can be assigned to different teams? So in this case, we have the server component and the client component, and we can split it up into two teams of different engineers. These can code in like React or Angular, and these guys can code in like Python and Django. So this is good to know. And if you are going in for an advanced interview, they may ask you even some estimation questions about how many people will it take to do that, and how much money do you need, and how long will it take to build such a system. And you should be able to provide like a back of the envelope estimation of how long the system will take. And of course, in these, you should also ask questions like, how many users do you plan to have in this system? Is one load balancer enough here? Or will the load balancer also be overloaded and you need multiple load balancers that are managed by some other technique like round-robin DNS or some different idea, right? So you should always keep asking questions about scalability, about the user base, about what kind of speed requirements do we have? Is this a real-time chat or is this like a forum? Because if it's a real-time chat, then maybe this kind of connection here needs to be a like a WebSocket, right? So this is different design. The other things you will be asked to talk about is network protocols and how they work. How does DNS work here? How does HTTP work here? How does SSL and TLS work? And how does WebSockets work? Yeah, and then maybe you will be asked to optimize some things. So if you designed a normalized DB schema, you may be asked to denormalize. So these are all kinds of things that you can be asked to do. And I can't really put my finger on what kind of thing they ask because each interviewer is different and they like different things, and they may ask you any part of the software. They may ask you about, for example, like, do you want to use UDP here? If this client is like a desktop client, would you use UDP? Like, that's a network question, and then you can explain what it is. Or they may ask you about compression. Would you use a compression method, right? There's all sorts of questions that they can ask you at this stage. Okay, so these are the this really sums up the interview, and I want to say, let's just go back to like the three core areas again, and just do an overview. So we said you need coding, you need algos, and you need software design. And what you will see is usually the first two questions are grouped together, right? So they may ask you an algorithm question and expect you to code it. So they may say something like the points on the map problem that I said before. You're given a map with x and y coordinates like that, and you're seeing some points here, and they're given in like in their coordinates, and then this is a big list of points, but they're static. And then you're given a point somewhere, and you need to find like the k closest neighbors, right? This is a classical algorithm problem, and you will be expected to solve the problem in a fast fashion, use the proper data structures, and code it up. Not code it up, but rather design it from an algorithmic point of view so that it's fast and analyze its complexity, and then you will be asked to code it in your language of choice, like C++, and you will be asked to write real code. So this could be like a 45-minute question, and if you do well, they may change the problem, and they may say, oh, actually, this is given in latitudes and longitudes, whatever, or now it's like a 3D space of points, and then you have to solve the same problem. And they may change a problem like that. It's quite common. It means you're doing well because they keep asking more questions. So you solved the previous one and you're asked more. And a lot of this algo stuff also involves some discrete mathematics and probabilities. So it's good to have some basic background in math. I would say just discrete and probabilities. It's very good to know in addition to your algorithms and complexities. They may even ask you to do like a simple probabilities proof. And then this is going to be one 45-minute question. And then the design question is going to be a different question. So a different interviewer will ask you your design question, and that's going to be another 45 minutes. So as I said, you will get 5 interviews, meaning you'll get maybe like 3 coding and algorithms questions and 2 design questions, something like that. Or maybe you get 2 and 2, like 2 coding and algorithms questions and 2 design questions, and then one question is more specialized. So it could be a probability proof. Or maybe it could be like a security interview where they show you some code and they tell you, oh, do you see a security mistake in this code? Depending on what the interviewer wants to ask you. Yeah, so that sums up the different questions that could be asked. Well, I hope you liked this video and that you learned something about how big companies conduct software interviews. As you saw through the video, it's not possible to fake your performance in the interview because they ask you all sorts of things and you should really know how to develop software. So the best strategy for getting through one of these interviews is to just know how to write code and how to solve algorithmic problems and how to design software. And in addition to reading the books that I mentioned, I think one of the best ways to get up to speed is to spend several months or maybe a couple of years writing software for open source projects and contributing to open source projects. If you spend 1 year working on an open source project, you will have the chance to work with more experienced people that will show you how to properly design software and how to write good quality code. And of course, you should choose a project that has good practices and good leaders. And there's many out there that you can choose from. You can just go on GitHub, click on Explore, find a project that is in the programming language of your choice or that you personally use, and you can go ahead and write a small patch and go from there. Now, another way that I would recommend you train is ask a friend who is more experienced than you, or even someone who has worked for a larger company, to do a mock interview for you. So sit together and tell them to ask you questions about your skills, right? Explain to your friend that you would like to interview for a big company, and tell her to mock the interview for you. Tell her to ask you specific questions as they would if they were conducting an interview for their company. So tell them to give you an algorithmic problem or a software design problem without spoiling the solution, and try to assess you and to give you some feedback. That would be great for seeing what you're missing in terms of knowledge, but also it will help reduce your stress before the actual interview. Well, I hope these are some good tips, and good luck with your interview. If you found these tips helpful, please thumbs up, and if you haven't already done so, don't forget to subscribe. And if you have questions about the interview process or anything else, don't forget to leave a comment in the section below. Now, till next time, so long.